Hello, welcome to Unit 6. Today we're going to start similar triangles or similar figures, okay? Because to be honest, a rectangle and a larger rectangle are similar to each other. So congruent figures are formed by rigid motions. And the three rigid motions we discussed back in Unit 2, I believe we did it this year, was translations, rotations, and reflections. So remember, congruent figures, if I draw one triangle and an identical triangle, congruent figures have corresponding as I'm spelling this wrong, sorry about that, corresponding sides that are congruent and angles are congruent. So with that said, if we have three angles of a triangle, one angle, two angles, and the third angle, whatever this measure is, let's say 60 degrees would match this one, maybe 70 degrees up there, 50 degrees over here. Now, all three sets of angles are congruent. Well, we also had, for congruent figures, three sets of equal sides. Okay, so the left side would be one dash, double dash, triple dash. Okay. So again, we did congruent figures back in Unit 3. We did congruent triangles. We proved these congruent by side, 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 angle, side, angle, side, angle, 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 side, HO. So that's old. What we're kind of moving over into is similar figures. And similar figures are formed by dilation. And with dilations, we also determine scale factor. So if I have this nice little equilateral triangle with three equal sides, and I dilate it by 2, twice as large, these two triangles are said to be similar. Okay, so this is a symbol for similarity. It's a squiggle, okay? No equals. So this is the symbol for congruent. This is the symbol for similar, meaning triangle ABC is similar to triangle DEF. Okay. And with that said, if A to B is a length of, let's say, 2 centimeters, and I dilate it twice as big, and we did a couple dilations in our last unit, it's now 4 centimeters. Well, if this triangle is equilateral, 2 to 4, this side would be 2 as well, right? This side would be 4. Equilateral, this corresponding side would be 2 centimeters, and this corresponding would now be 4 centimeters. Okay? So in this case, when we have similar figures, our sides are not equal to each other. So this side AB is not equal to DE, but sides here are proportional. And we have a little reminder about what a proportion is here in a second. So sides are proportional, and to be honest, the angles do stay congruent, because again, I called this an equilateral triangle, and we remember that equilateral triangles have three equal angles that are all 60, 60, and 60. Even though I take that triangle, right, and I'm trying to use my hands here to kind of show you a little triangle, if I make it any larger, okay, did the angle here between my forefinger and my thumb change as I opened up my triangle? It doesn't. Okay? So the angle measures stay the same. That's a key piece of these dilations, is that these angles are still going to stay 60 degrees. Okay? Because angles in a triangle, their sum will have to stay as 180. If we doubled them, then it wouldn't add to 180 anymore. Okay? Similar polygons must have corresponding angles that are congruent and corresponding sides that are in a proportion. So again, up here we kind of just highlighted the differences between congruent figures and similar figures. Excuse me. And now we're going to move on to talking about these proportions. Okay? A proportion is when two ratios are set equal. Right? And we saw some ratios. So remember a ratio? We had breaking things into a 1:3 ratio, or we could do 1/4 parts, a fourth. Okay, is how we used that with our directed line segment equations. Okay, so a ratio is when you compare two numbers, 1:3, or 1/4 parts total. Okay, a proportion is when two of those ratios are set equal to each other. And how we solve proportions, so a fraction, a ratio, set equal to a ratio, okay, we solve these using cross products. So if we cross multiply 5 times x plus 2, a little reminder is this x plus 2 has got to be put in parentheses. So this is a little algebra refresher here. So 5 times x plus 2 equals 10 times 24. So again, this ratio and this ratio, we took the cross products. So remember that little butterfly, we multiplied across the diagonals. Well, 5 times x plus 2, if we solve this out, is 5x plus 10 equals 240. We would subtract 10 over, and if you need help with the solving, let us know. 5x equals 230. I pick up my handy calculator. 230 divided by 5 gives you that the x value is 46 there. So with that said, what we're going to have is missing pieces between two triangles, right? And we're going to be using proportions to solve for those parts. So that's where I wanted to just go over a proportion quickly. Moving on to exercise 1. Here we have a rectangle ABCD, with two side measurements given, and a second rectangle, EFGH, with a couple of measurements given. What I'd like to focus on is looking at a proportion of the corresponding sides. Now these proportions sometimes get students a little baffled to begin with. What I did here is I picked two sides, BA and DA. What I'd like to do is set up the other two pieces of this proportion to what corresponds to BA from one rectangle to the next, and then the other two. Okay, there's multiple different ways these pieces can go into the proportion, but as long as what matches on the top or on the bottom. So if we use highlighters to help here, BA compares to DA from this shape as, go over that in a different color, as FE would compare to HE. So filling in this proportion, BA corresponds to FE as DA corresponds to HE. So those are the four pieces. And here we have the digits given, and if I put the numbers in, 4 corresponds to the 10 as the 2 corresponds to the 5. And if we just look at those fractions for a second, 4/10 and 2/5 are equivalent, so that checks out. The order of where you put the pieces, okay, or how you start this, Again, you just have to make sure the corresponding pieces are in the same place. But your proportions might look different. Somebody else might look at these two pictures and say, oh, well, BA corresponds to FE. BA corresponds to FE as DA corresponds to HE. Okay? So I put those four pieces in a different order, but it still works out that this side compared to this side, 4 is to 2, as the 10 matches with the 5. Okay? So that digits-wise would be 4 relates to 2 as 10 relates to 5. And these two fractions equal out. If we reduce this one, it would become 2. 5 divided by 10. 10 divided by 5 is also 2. Okay. So these proportions, how you set them up, as long as you're careful to go from a corresponding piece over, they might look different depending on how you look at your questions. Okay. So exercise 2, we're going to be setting up proportions to solve. Given triangle ABC is similar to triangle DEF. So again, the fact that the triangles are similar tells us that the sides are proportional and angles are congruent. We already kind of marked in the angles for us. The A is congruent to D, is how they correspond. B and E are congruent, C and F are congruent. So setting up a proportion. I have 4 digits on my diagrams. I have a 10, a 6, an X, and a 12. Okay? We need to fill those 4 pieces into this proportion, a numerator to denominator, numerator to denominator. So how I'm going to write it is 10 corresponds to X, as 6 corresponds to 12. And then we can solve from there. So we'll take our cross products and keep going. Right? So again, we use those 4 missing pieces to set up a proportion of what parts correspond. So AB compares to DE as 6 compares to 12. So cross multiplying, we get 6x, 6 times x, equals 10 times 12 is 120, making x 20. So that says that D to E would be a length of 20 units long. Some of you might have written your proportion a little bit different, and I just want to show you option 2. Some of you might look at 2 pieces within the same picture. So here, again, we started at the left triangle to the right, the left triangle to the right. We could have also said the left side of the triangle 10 compares to 6 as the x compares to 12. So in that case, we still get the same cross product. So the digits are in a different position in our proportion, like the x and the 6 are in different places here. However, our cross products, 6x and 120, are the same. Okay? So that's just to show you, pick 2 numbers, 10 and x or 10 and 6, and set up the other ratio to match with those pieces. We're going to practice a few more, and then you'll have classwork today. So looking at exercise 3. These are words. These words relate to a picture. Okay? So similar to all the other topics we've done this year, your quadrilaterals, your parallelograms, your rectangles, rhombus, please, please, please draw a diagram based on the phrases. Okay? The sides of a triangle are 5, 6, and 10. The length of the longest side of a similar triangle, finds the length of the longest side of a similar triangle whose shortest side is 15. So we're going to draw 2 similar triangles. Okay, so this little arrow here is going to say to draw pictures. Some of you get a bit lazy and you see numbers and you're like, oh, I see 5 and 15. You multiply. Okay. But really drawing the pictures and visualizing the whole problem is going to help us out. So the sides of a triangle are 5, 6, and 10. 5, 6, and 10. And with drawing your pictures, just know that sometimes they're not going to be drawn to scale. Find the length of the longest side. Well, if this is the longest side for the first triangle, then this is going to be the longest side for the missing triangle. So find the length of the longest side, that's going to be x. That's what we're looking for. So you always need your variable. Okay? So find the longest side of a similar triangle whose shortest side is 15. Well, this has got to be the short side. 5 is the shortest. So the new short side here is going to be 15. So there are our corresponding pieces. The short side compares to the short side as the long side compares to the long side. So we're going to write a proportion. 5 compares to 15 as 10 compares to x. 5 compares to 15 as 10 compares to x. So I went from here to here, here to here as I set up my proportion. 5x equals 150. We divide by 5. X is going to be 30. That's it. So you read the question, set up a picture, use your picture to make a proportion. Again, putting the variable onto your diagram is a common mistake I've seen. Exercise 4. At a certain time of day, the shadow of a 5-foot boy is 8 feet long. The shadow of a tree at the same time is 28 foot long. So this I call the shadow problem. And the reason the shadow problem becomes similar figures is because of this. So let's kind of draw this out. We have the sun off in the sky. Right? The rays of the sun coming down, okay, make triangles. Right? So what I'm going to do is from the sun straight down to the ground is how high the sun would be, right? Straight across, and the rays of the sun kind of come down at an angle. Certain time of day, the shadow of a 5-foot boy is 8 feet long. So if we have a boy here, he is 5 feet tall, and his shadow to the ground, and again, we assume that the boy is perpendicular to the ground. Okay? 5-foot boy becomes 8 feet is the shadow on the ground. The shadow of a tree at the same time of day. So again, we have a right triangle formed here because the rays of the sun are coming down, and that's what creates the shadow down on the ground. Okay. Same time of day, we have a tree. We're going to assume the tree and the boy are standing on the same level ground. Okay. That tree is here, and the shadow of its tree is 28 feet long. So from the base of the tree across, the shadow is 28 feet long. So we have two right triangles formed. We have the boy and his shadow, 5 feet tall, shadow is 8 feet. Then we have the tree and its shadow, which is 28 feet long. How tall is the tree? So that's our variable. So we're going to set up a proportion. 5 compares to 8 as x, the tree, compares to its shadow, 28. So I put the shadow measurements in the denominators, the heights of the two objects in the numerators. So taking cross products, we get 8x equals 5 times 28, gives us 140. And we divide by 8 to get x equals 17.5 feet. So that tree is 17.5 feet tall. I guess it's redundant, right? We don't need the apostrophe to say foot if I'm going to write the word feet, so I'll take that out. Okay. So those shadow problems, you'll see one in your classwork today. Overlapping triangle. Okay. My hint here is redraw the triangle separately and set up a proportion. Because what happens here is this X, you have to understand what it's representing. It's representing a part of this whole side. All right. So when we redraw the triangles, that small triangle, so again, this would be our center of dilation. 2 became 8, 5 becomes something, but we're looking for this little measurement here. So that small triangle has a side of 5 and a side of 2. The larger triangle, we know the bottom here is 8. So 2 compares with 8. But what does 5 compare with? Okay, 5 compares with the whole side. So this piece from here to here is 5, and then from here to here is some measurement we're looking for. The entire measurement is 5 add x. So that's a little key piece here, is you have to add those two parts together, because when you're trying to find the whole length, you need to add the two pieces. So this side is 5 plus x. So there's our proportion. 5 compares to 2, as 5 plus x compares to 8. So 5 compares to 2, as 5 plus x compares to 8. Now when we take our cross products, we get 2 times 5 plus x. Now again, this is where we need some parentheses, and we reviewed one of these on the front. Need some parentheses there to remember to distribute. So 2 times 5 plus x equals 5 times 8 to be 40. Don't forget your equals between your two products. That's another mistake I see often with the algebra here. 2 times 5 is 10, plus 2x equals 40. Over 10 over, 2x is 30, making x 15. So in that context, this measurement from here to here is 15. Now some of you can do this using scale factors, okay? Up here, with these proportions, some of you go, oh, from 5 to get to 15, they dilated by 3. So if this side is 10, it becomes 30, okay? Some of you mathematically, automatically, you'll do that in your head. You would have to identify these scale factors. Okay? Some of you might say your scale factor here from 2 to 8 is dilated 4 times bigger. Okay? Well, 5 times 4 gives me 20. So where's this 15 coming from? Well, this whole thing is 20. And if I already have 5 kind of accounted for here, the rest of that side would be 15. So there are a couple ways to think about these questions. I'm not trying to just hone in and force you into one method using these proportions, but I'm going to tell you these proportions, setting two ratios equal, will never, ever, ever fail, okay? As long as you're doing the corresponding pieces in the same order. Students who try to use the scale factors sometimes get some funky answers, especially when you have some decimals attributed there. Exercise 6 is an exercise about the angles of similar figures, okay? So in exercise 6, let's remember that angles of similar triangles are congruent in their measure. Again, if I go back to that equilateral triangle, dilated bigger, these angle measures still become 60 degrees, even though it's small or big. And another little hint here is to draw a picture. So if triangle ABC is similar to ZXY, so we're going to have two triangles, and I'm just kind of drawing them, one small, one big, because similar triangles are not the same size. Okay. We have triangle ABC. Now be careful with your corresponding pieces. A and Z are the same measures. So remember, the first letter here and the first letter there are important. Z and A are equal. Just trying to cross out my Z there, sorry. B is the same as x. C and y are the same. So again, whatever measure angle A is here in the small triangle would correspond to its piece Z over here is also going to be 50 degrees. So if angle A is 50, Z will be 50 because angles of similar triangles are congruent. If C is 30, then Y is 30. So now that I've drawn a picture and the other picture, what's the measure of angle X? So that's what we're looking for. It should be 100 degrees. How come? Well, 50 and 30 adds to 80. All angles add to 180. We're left over with 100 degrees there. So that's your notes in a nutshell. Try to keep it short and sweet today. Again, you're rather setting up proportions because you're talking about the sides of a triangle, or the angle measures here are going to be congruent. So looking at a couple of your classwork questions to give you a few hints. If you read all these words, it'll help. In the diagram below, these triangles are similar, but the lengths is marked. Set up proportions to solve for them and find the missing sides of DE and F. So with this case, we need to know what DE is. I'm going to put an X there. And I'd like to know what DF is. We'd like you to put a Y there. So I'd like two proportions. I'd like you to set up a proportion to find X, and then maybe another proportion to find Y. And I'll help you with the X. 10 and X are in the same positions, so I would say 10 compares to X. As 20 compares to Y wouldn't work because then I'd have two variables in my proportion. So I'm going to forget about the hypotenuse-ish measurements. I can't say hypotenuse because it's not a right triangle. But I'm going to use this 14 and 35. That's a constant. This side is 14, it becomes 35. Okay? So 10 is to X as 14 is to 35. You want a proportion that has 3 digits in it, at least, or the same variable, okay? So when you're finding different sides, we assign different variables. So you're going to solve here for X, and then set up your own proportion to find Y over there. This is another shadow problem. If it helps you to redraw the two triangles, the flag one, and the one with the person. Okay. Exercise 3, something I'll help you with is the corresponding pieces. EF is 3 compares to 5. So if that helps you at all, you start in this triangle, you have a 5 that compares to 3. You're going to set up the ratio of the other two pieces, probably X compared to X minus 4. So just a little hint is that 5 and 3 are the corresponding pieces, but this triangle, they kind of just rotated around and dilated a little bit smaller. Exercise 4, again, I gave you a little hint here. Draw two triangles separately, use a proportion. Scale factor, we're going to kind of skip over for now as your new over original. But your small triangle is a 6 and an X. This loop-de-loop tells you the whole side of your big triangle is X plus 13. And this little loop-de-loop here is telling you this whole side is X plus 5. So they'd like you to set up a proportion and find the value of X. There's a couple multiple choice practice questions for 5, 6, and 7. And here I gave you a little note. Please use notes 506 to help. The dilations and scale factor questions might help with these here. I guess that's where this meant to be. That's a typo on my behalf. This scale factor little box meant to be over on this side. So I'll write it here with you. Scale factor, remember if you're thinking of a proportion, is the new side over the old side. With that said, have a great day. Thank you.